Okay, today we are doing medium problem 1996 number of V characters in game. So we got each character has attack defense, and it is said weak if it has both attack and defense strictly, if there is someone that has strictly greater attack and defense both, and we should return their number. So now straight up thing, what we can do is we can order based on attack, and then we just keep maximum strength seen and maximum strength that is not maximum strength seen, and then we keep maximum defense seen. But problem is if we have like two fives, then if the first one had 6 and second one had more, so we had to order by the second key in ascending, no, in so we go backwards, and then we keep like the minimum strength or maximum strength in the suffix we have seen, and if it's greater, so I would start with 6 3, right, and go to 5 5, and I have seen defense of 3, meaning that out of the larger ones it doesn't have a bigger one, right? And then okay, and then I update 5, so I go to here and it still doesn't have a larger one, so there will be 0. Now problem is if there are ties, like if there is 5 6 and 5 5, so I have to in increasing order of strength and decreasing order of defense, because then I would process first 4 and then only 5, right? Okay, so but in reality, right, I want properties sort key lambda x, and we return pair of minus x0 because we want decreasing, and x1 since we flip, we want it decreasing but we flip it, right? And then we go ansys that, and then we go for prop in properties max def scene is this, and then we do how can they do, they have to positive? Yes. Okay, so if max def, well, it has to have both greater, I guess. If max def scene over prop 1, then ans plus equals 1, max def scene max should work. Great, so we are here. Now another approach we can do is that do we really have to sort? Because if, let's say here attack defense are 10 to 5, so let's say we make an array of 10 to 5, right, or max of attack, and for each attack we do this suffix sum of, right, we save the max defense there, and then if we have seen something larger, then right, so what I'm saying is that let's have an array and for each attack we store first what defenses were there, and then as we go backwards in the list we check, was there a larger, right? So we do the same thing, but we don't sort, because we simply iterate over that array. We iterate over properties, and then we iterate backwards through all those. So I mean, our solution was 64% and 84th in memory. Okay, so memory gonna be bad, time allegedly could be better. Okay, so let's do like m is equal to max of map lambda x0 of properties, and then we do else is list for I in range n+1, and then for attack defense in properties, we have to put this here to actually unpack it, and then else, and then maybe I enumerate attack append, and we don't need that, append defense as max def scene for in range m, like that. And now for defense in else attack, if current max is here, so now if defense if max def scene over defense as plus equals 1 current max current max and defense, and then max def scene max def scene cur max return ans. This should also work. Okay, that's a bit faster but memory shittier. Okay, so memory is like, I don't know, what do we call it, suffix maximum sorting plus suffix maximums o n log n, and let's do this o n plus k, right? So let's sort characters by attack and in non-decreasing order, and then let's go backwards, and character is weak if from the previous characters we have seen larger defense, so we keep maximum suffix defense to avoid problems with duplicate with characters with same attack. we so in case of ties on attack, we sort based on defense decreasing. Can we avoid sorting with use of some extra memory? Yes, since attack and defense are only up to 10 to 5, store all defenses, so we will have a defenses list where defenses attack is just a list of defenses with a given attack. Then we again just go backwards, and then we again just go backwards and keep suffix sum. If to avoid problems with same attack and still not sort, we keep current maximum, or we only update the suffix maximum after processing all defenses of for a given attack, which we store their maximum defense we store in a separate variable. And login for sorting, since we first sort and then just do O1 work per property per character for all characters, O n plus is the number of characters, the maximum attack, since we first store all defenses in on and then iterate over all attacks. In on plus k. Okay, and then for memory complexity we get, do we even do anything here in the sorting solution? No, O1 for sorting, since we sort in place and then just keep a few variables. Okay, no, n plus k for no sorting approach, since we have to store all attacks, and in that list we store all characters. Technically it's okay, but technically no, but store all and characters. Okay, goodbye.